Simply select the FBD tool from the toolbar and attach it to the desired object. You can see all the forces which are acting on the body. Now, using the FBD scale, you can adjust the length of the force vectors. Use the display mode icon to customize the free body diagrams. For example, the force components mode lets you display X, Y components of all the forces. The force value mode lets you display the values of all the forces. Click the Preferences icon from the menu bar and select the third tab called FBD. This is where you can choose to show or hide certain force types. Dragging the mouse cursor while keeping the Control key pressed lets you select all or any desired bodies. Then, after right-clicking over the body, select Group from the Selection tab. As you've noticed, all the internal forces between the selected bodies have disappeared, giving us the combined FBD of the system.
Simply select the tracer tool from the toolbar and attach it to any number of points on the desired object. Now, using the velocity scale, you can adjust the length of the tracer vectors. Use the display mode icon to customize the tracing path. For example, the acceleration mode lets you display the acceleration vector of the selected points. The value mode lets you display the values of all the vectors. Now, select the tracer tool, then under Pattern, you will see three options. Let's explore ghosting for now. This option creates images of the selected object in regular intervals which can be changed from here. Num points decides the number of tracing points shown at any given moment. Also, size of the tracer can be changed from here. Consider projectile motion, where horizontal component of the velocity remains same at any position and the vertical component gets inverted for positions with the same y-coordinate. Now, attach two tracers on the rolling disc, one in the center and the other on the topmost point. Notice that the velocity of the topmost point is double that of the center since the disc is performing pure rolling. Now, attach the tracer while choosing the acceleration from the display mode to the topmost point. Notice that the direction of the acceleration is towards the center since our point is performing circular motion about the center. Consider the monkey hunter simulation. This is how it looks in the frame of ground. If we attach the camera tool to the monkey, and decrease the simulation speed, then notice that the bullet travels in straight line while rotating on its axis with respect to the monkey. Consider another simulation. The small block kept over the larger block is moving towards left with respect to ground. But if we attach the camera tool to the larger block, the small block moves towards right. This is happening because of the pseudo-force acting on it, which is evident using the FBD tool. Consider this simulation. A disk is rotating with constant angular velocity and the block is at rest with respect to the ground. Now, attach camera to the rotating disk, and check the Allow Rotation checkbox from the subtoolbar. Notice that the block starts rotating in the frame of the rotating disk. If we attach FBD tool to the block, we observe a pseudo-force acting on it, which is responsible for its circular motion. Consider another simulation. Here also the disk is rotating with constant angular velocity, but the block is kept over it and is oscillating between the two walls in a straight line. If we attach the tracer tool on the block and attach the camera tool over the disk, we can observe Coriolis force in action. In this video, we will learn to represent various quantities graphically in SimPhi. Simply select the Graph tool and attach it to the desired object. Now, from the Graph window, under Body 1 and Body 2 menu, you can select the quantities to be represented on y-axis and x-axis respectively. You can also plot multiple graphs, as long as the quantities have the same units. Moreover, SimPhi allows you to plot any custom graph using just a few lines of code. Use the Set Custom Script function, which requires 4 parameters. First one is the function you want to plot, in this case potential energy. The next 3 are for labels for the graph, which are its name, its symbol and its unit, and finally set the index as 0 for now. Similarly, plot the kinetic energy and the total energy in the same graph window using scripting. Use the checkbox at the bottom to show or hide the values, grids and legends. If you're plotting time on the x-axis, then by default, you can see the graph for 6 seconds, which can be changed using the timespan slider. All graphs record data in every 0.01 seconds by default, which can be changed from the time interval slider. The lesser the time interval, the smoother the graph. Set the appropriate time interval for which you want to record the data and click the Export button to export the data into a CSV file. Hope you got an idea of all the visualizing tools in SimFi.